Welcome back to teaching the series on FluidSIM. As I promised, the focus of this video is going to be on signal overlapping. First, we discuss what is a signal overlapping with one example, and then I'll show you guys how you can basically eliminate the case of signal overlapping by changing the actuation mechanism for the directional control valve that you have within a pneumatic circuit. So, the first thing that we are going to learn what is a signal overlapping, and the second thing that we are going to learn today is how we can eliminate the case of signal overlapping within a pneumatic circuit. Without further ado, let's start. So signal overlapping, as I said, you can basically understand from the name. We have overlapping of signals, which means probably we have a components, and in that component we have multiple signals coming at the same time, right? Now let's focus at this specific example that I have in here. For this pneumatic circuit, you see we have two actuators, right? And we have 5 directional control valves with 3 ways and 2 positions, and 2 directional control valve with 5 ways, 2 positions. And if you look like in the left side of this basically circuit, you see we have a push button, right? A spring return, directional control valve 1S1, right? And here we have another one, which is a directional control valve, and that directional control valve is already actuated. How we can understand this is already actuated based on this symbol, right? So it means it is already actuated. And if we look at 1S2, we'll see there is a link between 1S2 and the position of the first actuator that we have in this pneumatic circuit. So whenever this actuator is in fully retracted position, basically this directional control valve is going to be actuated. And now we are in fully retracted position, therefore this is fully actuated. Now let's look at this one, 2S1. If we look at 2S1, you see again this one is already actuated based on the symbol that you can see here, right? So, and basically this one is connected to the position of this piston inside the second actuator. Whenever that piston is in fully retracted position, this one is going to be actuated, which means we can pass the air from this arrow, right? And from there we have this basically port 12 actuated. Therefore this directional control valve is in actuation form. Now let's look at this side. If I actuate, we have one operator, and the operator actuates this directional control valve. What will happen is basically the air will pass and reach to this port 1 of this twin pressure valve, and currently we have the air on the other port, which means both conditions for the twin pressure valve is true, right? From there the air can pass to port number 2 because we have air from both sides. Therefore this twin pressure valve will pass the air to the output port, and therefore the second basically actuation part, this pneumatic actuation, will actuate this directional control valve. And we already have an actuation from the other side, and once we get this actuation from the other side, we have a confusing signal there, right? Because this directional control valve, this one 1V2, cannot understand what's going on because initially it is getting a signal from number 12. However, this one is in fully retracted position, so it cannot do anything, right? And at the same time, if the operator is pushing this button, this directional control valve is going to be actuated from the left side, right? So we have actuation from both sides. Therefore, this directional control valve cannot operate anymore, and the cycle is going to stop. So this is the case of signal overlapping. We have 2 signals coming to a directional control valve, which should basically pass the air to another component, but because it is basically getting the signal from both sides, it cannot understand which way, actually which position it should take, right? And from there, the system is not operating anymore. And this is the first signal overlapping case that we have in here. If we look at this displacement step diagram, you see we have 1s1, and it should be basically started, right? We need to have an operator to start it. And you see the other thing is we have 1s2 there, right? And that is in actuation mode, which means both of them should be actuated at the same time, right? But the system cannot work because of this 2s1, right? Because the 2s1 is going to be in actuation mode in that specific condition, and as we discussed, the system cannot operate anymore. Now let's say we somehow eliminate this case and the system can pass the first step. So I'll show you how we can eliminate, but for now let's assume we somehow fix this issue, right? So what will happen is, okay, we have basically this one fixed. There is no signal overlapping right now. This number 14 will shift this basically directional control valve to its second position. Air will pass through this arrow and the air get inside this double acting cylinder and it pushes it basically forward towards 1s3. Now when this piston reaches to the position of 1s3, because its position is linked here to this one, right, this is going to be shifted. The air will pass through this arrow and it will get to number 14, and that will actuate this directional control valve. Air will pass through this arrow, get inside this double acting cylinder, and pressure builds up the force needed. Therefore this is going to basically move towards 2s2. We reach to the second position. Now we are in the second position, 2s2, right? And when we reach to that specific position, that basically, because that position is linked to this directional control valve, this is going to be actuated, right? But there is an issue over there because we already have 1s3 in the actuated mode, because this piston, when it reaches to 1s3, this is going to stay in actuated mode, right? And once we have this one actuated, again we have another case of signal overlapping. This directional control valve is actuated from both sides, therefore the cycle is going to stop. The system is not operating anymore. And again, we have to find a way for fixing this issue, which is basically the signal overlapping case. In general, when we are designing a pneumatic circuit, we have to consider two important steps. Whenever you are designing a pneumatic circuit in which you have multiple actuators, the first thing that you have to do after thinking about the design procedures is drawing the displacement step diagram, because the displacement step diagram will show you if the system is going to operate accurately, and also there is no signal overlapping. It will show you guys everything related to the sequences and different steps that you have there. So you have to follow this step for sure whenever you are designing a pneumatic circuit in which you have multiple actuators. The second point is using a simulation software. So when you design a pneumatic circuit, you have to look and then find a proper software like FluidSIM, and inside FluidSIM design that specific circuit, ensuring that circuit is working properly and the components that you have selected is a perfect choice for that specific application. Okay, so these are important steps whenever you are dealing with design of a pneumatic circuit. Now we have signal overlapping in here. How can we fix this issue? Let's move. Basically, I'm not going to explain this slide. Let's move to the case that we want to basically fix the signal overlapping. Because we have the case of signal overlapping, one idea is to change the actuation mechanism that we have in here, right? So we can change the actuation mechanism of directional control valve to roller lever valve with idle return. And when we choose that one, The other step that we have to do basically is we have to link again the position of basically the piston to that a specific form of actuation. But this time, instead of using the very first position, let's say the fully retracted position and fully advanced position, we will use a bit before fully retracted position and a bit before fully advanced position. Let's say if the maximum stroke is between 0 to 100 for fully retracted, I'll choose 1 millimeter for example, and for fully advanced I'll choose 99 millimeters. And from there we can avoid the case of signal overlapping. So that is one approach for fixing this issue, but there are a few disadvantages for that. Let's see what are those disadvantages. So one point is, because instead of fully retracted position we are choosing a bit before it, and for fully advanced position we are choosing again a bit before it, we cannot sense the end and basically the initial position accurately. And another point is function may be impaired as a result of contamination. So that is another issue that we can have. And also fast control system are not possible when we are dealing with this type of actuation. Let's get back to the initial circuit that we saw. For this one, I already designed the circuit and I want to show you a short video to see how the signal overlapping is affecting the behavior of the circuit in here. Okay, so what we have in here, let me start this video. So as you can see, when we push this button, right, let me stop it. So when we push this button, the circuit is not operating anymore, and at the beginning this one was actuated, right, and the air is passed and it is basically here, you see it is in the actuation mode. And once we actuate this one, because this one is already in the actuated mode, this twin pressure valve will pass the air to this basically directional control valve, and from there we have the confusing signals, right, because we have two signals coming at the same time to this directional control valve and it cannot operate anymore. So this is the first case of signal overlapping happening in here. And how we can fix it, I already discussed what we can use for it. So in the next basically video, I'll show you how this can be fixed. So I said we can use either return valve, right? So this video is representing that. These are either return valves, right? You see, now we have the full cycle without any challenge regarding that signal overlapping for both steps. Okay, so for the signal overlapping, as I said, generally we deal with directional control valves receiving signals from both sides, and they cannot decide about their positions, which position they should choose, and the cycle is going to stop there. And how we can fix it, one idea is to use basically roller level valve with idle return. In the next part of this video, I'll show you guys how you can basically design the circuit that we already discussed, and how we can basically replace the roller valve with this type of valves in order to ensure the circuit is operating perfectly. Okay, in the previous part of the video, we discussed what is signal overlapping, and we saw a pneumatic circuit with multiple actuators in which we had signal overlapping conditions. We also discussed how we can fix that case of signal overlapping inside the pneumatic circuit. Now let's start designing the circuit, the first one which has signal overlapping cases, and then let's see how we can avoid basically how we can eliminate those signal overlapping cases in here. Okay, as you might remember, we had two double acting cylinder and we also had directional control valves, the configurable one. Two of them were basically at 5 ports, so I'm just going to bring in 2 of them, and 5 of them with 3 ports, 2 positions. Okay. Bringing all of them one by one. And we also had a twin pressure valve. Twin pressure valve is in flow control valves, as you might remember, based on our video on twin pressure valve and shuttle valve. So if you want to basically review those concepts, those videos, the video related to twin pressure valve and shuttle valve might help you guys to understand how this component works and what we have inside these components. So now we have most of the main components. I just need to bring the supply element. I'm not going to use air service unit and manifold. I'm just going to basically use the supply element for each of these components, but in the actual case you might have one supply or two supply elements, and then you have to use manifold to distribute the air between different components. So I'm going to bring the supply element here, and then another one for this one, another one for this one. So for each of these directional control valves, I'm going to bring one supply element. So that is going to make my life easier in terms of connecting components. And the circuit that I'm going to show you guys at the end is going to be a bit more well organized. Another one here. Now all components has their basically the supply element. It's time to configure each of these basically directional control valve. So for the first one, as you might remember, it was in the form of, so the name was 1S1, right? And for configuration, we need to have push button, and the right side is going to be a spring return. And also we need to change this terminator added here. So that is going to be basically the exhaust that we need for this specific circuit. The other thing is in here for the second directional control valve, we are going to use a form of roller valve, which is a form of mechanical one, and this is a spring return, and the label for that is 1S2, right? And we also need to add a terminator here, and then we can connect. So connecting this one here. Now we have all connection needed for these two directional control valves. It's time to basically configure this one too. So from both sides, this is pneumatically actuated. So this is the first, this is the second, and then for this one we need to use again roller valve, the mechanical form of actuation, spring return, and putting the exhauster. The other thing that we need is label for this one. This is going to be connected to the fully retracted position of the second actuator, so we need to put 2, and that is going to be basically related to the fully retracted position of the second actuator, so we have 1 there. So that is going to be 2S1. And now it's time to connect these components one by one. This is going to be connected here, and for this one we are basically connecting this directional control valve to this actuation part, and the very last part is actually connecting here these two ports, and from there we're almost done for this. Just need to put the terminator for this directional control valve, and the same thing for this port. And putting the labels, this is going to be called 1v2, and this is going to be called 1v1, and then OK. And this is our first actuator, so I'm going to call it 1A. So we are done with this actuator basically, in terms of connecting parts, in terms of directional control valves. But this side we have to again configure different parts that we have. So first, this is again going to be mechanical actuation, spring return, hit OK. The same thing for this one, mechanical actuation, we need to configure it. So configure spring return and OK. And this side we are going to have pneumatic actuation, and connecting this part to here, and connecting this part to here too. And this is going to be the terminator that should be added, and the same thing for this side, we need to add the terminator too, and hitting OK. This is going to be connected here, this is connected here, OK, and this is OK too. And now it's time to put basically the labels. This is going to be called 1S3, and this is going to be called 2S2. Okay, just need to check this one. Okay, now the other component is this one. Going to call it 2v1, and the actuator is going to be called 2A. Now we have all linking and everything is basically linked, but the next step is basically labeling the actuators and finding basically linking to the corresponding directional control valve. So for this one, the very first position is basically connected to 1S2, and very end position, the fully advanced position, is connected to actually 1S3. So if you go to labels, choosing 1S2, putting 0 here, and for this one 1S3, putting 100, and then OK. Now we have this one actuated, right, because that is at the beginning and that is representing the fully retracted position, and whenever it reaches to 1S3 we expect this one should be actuated. And for the second actuator, the fully retracted position is going to be connected to 2S1, and fully advanced position is going to be connected to 2S2. So we'll do the same here. One is going to be 2S1, putting 0, 2S2, 100, and why I'm choosing 100 here, if you go to the component parameters, the maximum stroke there is 100. So let's get back to actuating labels. So everything is set, hit OK. Now we have everything set in terms of actuating labels. So let's start see what will happen. So you see, as expected, because 2S1 is fully retracted, right, it is sensing that position basically and mechanically actuating this one, so it is in actuation status, therefore air can pass through there, right? And also for this one we have the same case for 1S1. So sorry, for 1s2. 1s2 is linked to this position of fully retracted position for 1a, therefore the air can pass from there, and that is in the status of actuation. Now if I start this push button, and if you look at this 1v2, it is already actuated from the other side, right, from the right side. And if I actuate this, I expect the air pass through this line. This is a twin pressure valve, needs to have the air from both sides, and once it gets the air from this side, it is already getting the air from the other side, therefore the air can pass through this output, and from there we will have the actuation from both sides, and that is the first case of signal overlapping. So let's do it. You see, that is what we expect, right? Because if we basically, once I'm pushing this button, right, the air is coming from both sides, therefore this directional control valve cannot do anything because it is confused with the signals that it is getting from both sides, as you can see in here. Now let's avoid this case and basically eliminate this signal overlapping, the first one. As I said, we can use idle roller level valve with idle return. And in order to basically avoid this, the first signal overlapping case, we have to basically remove this form of actuation that we have, right? We have to update and use another one. So let's pause it, and I'm going to basically change this one to the form of this valve, this actuation, and then hit OK. Now this 2S1 is basically connected to the fully retracted position. As I said, this time I'm not going to consider that 0 value, fully retracted position. I'm going to look at a bit before, so I'm going to choose 1 millimeter for that. So let me put 1 millimeter here, and that is 1, 2, and hit OK. Now you see this is not actuated anymore, and if I start this simulation and push this button, you see we have the system is working there, right? Because we fixed that case of signal overlapping, and we can do the same thing for this one. So we can change this one because this one was also making issue for us. So what we can do is, instead of using this form of valve, I'm going to choose roller level valve with idle return, hit OK, and then in here for 1S3, instead of 100, I'm going to choose 99. Okay, so when I choose 99, the system will basically actuate it when it reaches to that point. Okay, so now let's say basically let's see how it works. So pushing this button, so we have the full actuation mechanism, right? And this 1S3 is not going to block and basically stop the system anymore in there. Okay, so this is how basically we can deal with the case of multiple actuation and signal overlapping, and how we basically can fix it with the use of roller level valve with idle return, as you saw in here. So as I said, for designing of pneumatic circuit, it is very important when you are dealing basically with multiple actuators to have a displacement step diagram handy, and at the same time having a FluidSIM software or simulation software in order to ensure the circuit that you designed is working properly. Thank you very much for watching this video. Hope you enjoyed and learned about the signal overlapping. If you enjoyed and learned about signal overlapping, please subscribe our channel.